Okay, so recording has started, so don't say anything controversial because I will post it on the internet. Okay, so I have in front of me an on-site W. It is not powered on and it is not connected to anything by anything. So this is normal starting point. So the first thing I'm going to do is turn the instrument on by pressing the big red button, and immediately the LED starts blinking green and then starts blinking blue. That means that it's looking for a Bluetooth system to connect to. And I should add that we know that the on-site W works with, it requires Windows 10. Part of Windows 10 is Bluetooth 4.0 and above. And we know that it works with Windows 10 Pro and Enterprise, and other versions of Windows 10 are a big gray area, so don't use them. Okay, so the first thing you've got to do is to pair it with the computer or tablet you're using. And so to do that, I'm going to click on the Windows 10 icon and bring up my Bluetooth settings like this. And I see I've already paired the instrument, and I can see in the list of devices here is my my on-site W with the correct serial number. So I'm going to remove that. And if you ever have trouble getting it to communicate with the computer, that's a thing to do, is to remove it and then re-pair it. Okay, so now I'm re-pairing it, and it says connected, your device is ready to go. That's good, it's normal. The LED turns solid blue for a second, and now it's back to blinking blue. So now that it's paired, we can start up the software. So this is MicroNIR Pro 3.0. And this is the minimum version number required to use the on-site W. So I'm going to log in.
Sorry, Ed, because they have a older on-site with a cable.
Yep.
But they still can use the 3.0. Yeah?
Yeah. The older on-site with the cable will work just fine under 3.0 and future versions. Okay, so here is my instrument. I launch it. And in this case, it's not working. So we start again. That sometimes happens the first time. And in this case, it has connected. The blue light goes solid, and that means that Bluetooth is communication is assured. Okay. So we go to developer space, and we look in configurations. The only significant difference between the operation of the on-site W and the other MicroNIRs is the on-site W requires a button press to collect a spectrum. So that means there is no continuous mode, no autonomous mode, nothing like that. So the number of options in the default configuration are reduced. The menu here shows, yes, we do have Bluetooth connection. Here's the instrument temperature. This icon means that we are using dynamic lamp control mode, which is the default mode, and that means we turn the lamps off whenever possible to conserve battery power. Here is the state of battery charge. This does not update very frequently, and that itself is in order to spare battery life. This time remaining is not correct, obviously, and that will be changed in a future version. Hang on a second, I'm going to have to get a reflectance target.
זיו, המכשיר, אתה מפעיל אותו גם כאילו באותו זמן?
מה זה? אני לא כל כך רוצה להתחבר.
Okay. I'm back. Right, so to use the instrument, we proceed as usual. We create a new project, which we will call test. We create a sample name, and we do a dark scan. For the on-site W, the dark scans are done with lamps off by default. So I press the button. There's my dark. I put it on top of the target. And while I'm scanning, the LED goes purple. That indicates that a scan is going on, and then it goes yellow to indicate that the data are being transferred to the computer. And now I press sample scan. And now I have to do one more thing that I didn't have to do with the other instruments, which is press the purple button. So I do that. And
so you need to press the sample scan.
I pressed scan. I press scan on the computer, and then I have to press the purple button to collect a scan. The purple button on the on-site W.
Okay.
And here is my absorption spectrum. This is a polyethylene bag. I press the purple button again, and I get another spectrum. And again, and I get another spectrum. And this will keep going basically forever. So that's data collection in the on-site in the MicroNIR Pro software. Okay, what else? Let's see. Ziv, do you know how to create a method?
No, maybe I know what maybe
Okay.
different.
So these, so when you're actually using the instrument to analyze samples, you're going to need a method to do that. A method which might include a model. So this part of the software is where you create a method. So let's go back to home a minute. Okay, so home screen, developer space, that's where we just were. Tools, that's where we create methods, and predict new samples, that's where we use the methods. So let's go and create a new method first. Let me see. Okay, so new method. We're going to create a new one, which we will call Tel Aviv, just for fun. And save it. And in workflow, we see here's where we add models to our method, and I'm going to add a PLS model that I have. And it won't be meaningful, but that's perfectly okay. Yeah, Performix DFB, that is perfectly fine. Okay, so add. I'm going to check these statistical parameters are going to be part of our method. Say OK. Go to output. I want all of these parameters printed as part of my method, and we can save that too. Okay. So save the method, and now it's available to us. So I go back home. Now I want to run that method in MicroNIR Pro. So here's the new method. I'm going to use, again, the project called test.
It's the same like the older version of the MicroNIR. We have the 2.3, I think.
Yeah, the workflow will be almost exactly the same.
That's the same. Okay.
Okay.
And
So
I understand for myself that I can develop my own models. This is what I want to know.
Precisely.
How can I do it on my own?
I'll go back to developer space in a minute and show you. So to run this method, we again do a dark scan. Again, do a reference scan with mouse clicks. And once more, I hit scan, and now again, I'm going to have to press the purple button on the on-site W. Okay, so here is my prediction with the two statistics that accompanied that method. So that's how that works. To create a model, the way you would do it is go into developer space, and let's say you wanted. Do you use moving block models typically, Ziv?
A PLS.
A PLS, okay. So to create a PLS model, again, you go to developer space. Go down here to data analysis and click on the PLS icon. So this will bring you into how to create a PLS model. So I'm going to create a new model, which we will also call Tel Aviv model. And I bring in my data here. And I retrieve data that I have previously obtained, which in this case, we'll get them from
in your case, Ziv, it's going to be all the scans you've done of the peas and sesame. So you're going to scan everything, you know the number of the scans, and then you're just going to retrieve it.
Can I retrieve it from older file that I have from the older version that's not installed in my computer?
Yes, you can.
Can I import the files?
Yeah, you can. You will have to import the files first, and in a little bit I'll show you how to do that. So here is the calibration data set. And the first thing I'm going to do with these is pre-process them to get rid of the baseline offset. So I'm going to use first derivative and standard normal variate transforms. So these data look pretty good. I could restrict the wavelength of analysis to just part of the spectrum. You know, probably this part right here is the best, but for these, so we can restrict it. What the hell? Let's go from 1300 to 1550.
You recommend to make a range of not use all the range?
No, it totally depends on the case, but you can see here that the in general I would recommend to start with the whole spectrum, and
okay.
then maybe go to restricted range and see if it helps with your prediction accuracy at all. It totally depends on the system, but you can see here that between 1300 and 1550, there's a lot more variance in the spectrum than at shorter wavelengths. Okay, so you see over here this red this button that says reference data has a red box around it. That means it wants help. So to give it the help, we're going to have to go here and tell it what the reference values are. And I chose this data set because I know what the reference values are from the file names. So that's pretty simple. So we'll call this reference value DFB, and it fills up with NANs. And then my job is to populate all these fields.
So here, Ziv, you put the variable name. You put like protein.
Protein.
In units, you put a percentage, and just put the numbers in front of the correct scan.
Yep. And this is kind of tedious to do by hand, but you can also copy and paste in an Excel column. But right now I'm just doing it by hand. Hopefully it won't take forever. I just collected these data last week, so I know they work. So I was looking at samples of a animal feed that had a insecticidal additive in it with values of anywhere from 2.5 to 3.5%, which is a fairly challenging application.
We have the same problem.
Yep.
With the range.
Yeah. So obviously using a bigger range makes your life easier. Okay. Right. Now we hit generate, and it asks us how many factors we should use, and in this case I'm going to say 3. And here is our here's our PLS window. Ziv, do you use Unscrambler at all?
No.
Okay.
No.
Okay. Well, then this looks very similar to the Unscrambler window. So the key thing is here, predicted versus reference, and you saw I had 3 different kinds of samples, 2.5, 3, and 3.5. And this plot doesn't look so good. But by default, it's only using 1 factor, and we can see here from the explained variance that we really need more factors to build a good model. So I'm going to right-click here and say...
You see it from where? From the explained variance?
Yeah, that's right. So what this tells me is that if I use 3 factors, it explains maybe 90%, 85% of the total variance in the sample set, which is, I would actually like to get closer to 100, so I might want to redo this with 4 factors. But there seems to be a lot of kind of random variation in here. So anyway, I want to show what this prediction looks like with 3 factors. So I'm going to right-click and select 3, and that's a little bit better. So I'm going to put on the target and regression lines. Here are the model statistics. The slope is 1.0, which is good. The intercept is close to 0. Here's the root mean squared error of calibration, which is not great. And here's R squared, which is also not great. So you would definitely want to acquire a lot more data before using this to build a good model with. And here are the regression coefficients, which is the PLS analog of the what is the word I'm looking for, Asaf?
What?
The loadings. This is the equivalent of the loadings in PCA space. This shows that below 1300 nanometers and above 1550, we're not using the spectrum at all. And that probably turned out to be a mistake. So we might want to go back and use the whole spectrum. Anyway, this is your PLS model. This is the scores plot, factor 1 versus factor 2. We can also display factor 1 versus factor 3, which looks a lot more reasonable. There's a lot of systematic variation in here, probably has to do with moisture in the sample that we haven't taken into account at all. That's probably what's mainly affecting factor 1 here. We can remove some of these points. So mark samples with rectangle, remove that point, and then I can regenerate the model without those samples if I want. And I can even do it with more factors. So let's see what I get there. So yeah, now we see that when I add 4 factors, my validation results actually get worse. So 4 was not a good move. Anyway, we have our 2 models here. I'm going to go back to the first one, and I save the model. And now I can use it. Do you have any questions about PLS before we move on?
How do you decide how many factors to use, or the default is free?
Just a guess. Just a guess.
Okay.
I know that there's supposedly only one factor that is varying in these samples, which is the concentration of DFB, but when we look at the data, we can see that there's more than that going on. So these data really need to be cleaned up some. So what you have to do is, build a model, see how well it predicts on a test set, maybe change the number of factors, go back, run it again, and see how well it predicts on the same test set. Okay, so there's my model. I'm going to go back home, and now I'm going to take that model and build it into a method. So back to Tools, back to Instrument and Method Configuration. Here's my method. And I'm going to take this method now and adjust it. So let's go back to Workflow. Viavi PLS. We're going to get rid of that previous model. I'm going to uncheck the Performix box and put in the Tel Aviv box. And here are my statistical parameters. I can put in alarms and warnings if I like. Okay. And save it and go back here and run the model in exactly the same way that I did before. So now, run the method in the same way that I did before. So now my method is updated with the new PLS model that I just generated. Okay, now the on-site W has another feature, which is that it comes with a special dumbed down app, which we call the tablet app or the on-site W app, which is really just meant for prediction. So to run that app, I first need to synchronize the method that I have just created to the app. So the way I do that is this. I go to Tools, go to User Setup, and by default in MicroNIR Pro, every user can use the methods that he himself has created, but if he hasn't created them, he needs to have someone assign him that method. So I created that method, so I have right to it, but if you logged in as analyst, you see the analyst does not, here's a list of all the methods I've got on my computer. The analyst does not have the Tel Aviv method until I check that box and hit save. I'm going to use me for the purposes of this explanation. So I shouldn't have to worry about that. So admin, that's me, and you see I have right to all the methods that are available. So I'm going to have to sync the Tel Aviv method to the on-site W app, and the way I do that is this. I click here to highlight it, and now I have to go and open up the on-site W app, which is over here. And I'm going to start up the app, and get into the login screen, but I'm not going to log in yet. So I'm going to minimize it. And now I'm going to hit the synchronize button. And if I had the app open on a tablet, which was remote from my desktop, I would keep this radio button checked. And both the tablet and my desktop would have to be on the same network for this to work. In this case, they're both running on the same machine. So I'm going to check this button and say OK.
And this is good for you, Ziv, because when you send the instrument abroad with the other people, you can, change method or build method and just they can use it there.
Yep. Okay. So
no, I cannot send them because they have to be at the same network. They have to be at the same network as I am. It's nice to. This is the way to connect. I understand this is the way to connect the tablet.
Right.
Not someone abroad because we don't use the same network. So I need to do all
the same network, Ed?
Yeah, you have to be on the same network.
Okay.
Okay, so the sync worked. So we should be ready to go with the on-site W app. So I'm going to quit this software.
How do I install the app on the tablet? Just look
it
up on the internet?
It comes with the.
It's on a stick.
You should be able to get it with the stick. So they should be in the distributor Dropbox, the installers.
Yeah, but how can I install it on the tablet because I cannot connect to the USB?
Then you'll need to put it on your network and install it from there.
Okay. Well, this is Dropbox or so.
Yeah. Okay, so I have quit MicroNIR Pro, and now I'm going to log in to the on-site W app, and I'm going to use the same login and password. And I forgot to wake up the on-site W. It timed out. So I'm going to have to log in again. So I've woken it up. The blue light is flashing, and now it should be connectable. Okay, the blue light went solid. That's a good thing. So here are all the methods that are on this instrument, including the Tel Aviv method, which I just synced.
This is the main window?
This is the home screen of the on-site W app.
Okay.
So to run this method, I go like this. I need to put in a sample ID. And so it's very visual. It says, put the sensor on the reference and press the button. So there are no mouse clicks here. So I press the button, and now it's doing a dark and a reference scan sequentially. Okay. And now I put the sensor on the sample, and I press the button again.
Okay,
and here are the results. So here's the predicted concentration. Here are the 3 scores, and here are the statistics. So if I want another sample, I click the button again, and I get another result. And these results can be uploaded back to the MicroNIR Pro if necessary. This thing here, if I had a barcode scanner on my computer, I could use it, but I don't. Let's see, what else can I show you here?
How can I export the data from the app?
That's a good question. I don't. I think I have to go back into MicroNIR Pro and do that. I don't remember off the top of my head, but it's covered in the manual. We can look it up later. These are pretty much the only diagnostics I have. Here's the dark, here's the reference, and here are the sample spectra that I just collected. What is this? That's probably help. Yep. Okay. Yeah. So that is that's the On-Site W app right there. Any questions about that?
Just the one that I asked.
Yep. Okay. So let's quit that. And now let's open up MicroNIR Pro again. The reason I'm quitting these softwares before starting the new one is because I can only connect the On-Site W to one application at a time. Okay, so where is it? No, it's not in there. Maybe it's in user setup. I don't remember. Yeah, I'll have to get back to you on that. Or we can, what the hell, we can look it up in the manual. So, MicroNIR. Manuals. On-Site W application manual. Let's see where this takes us. Okay, uploading data and results to MicroNIR Pro software. So disconnect the On-Site W and leave the application open at the login page. Start Pro that shares a network connection. There we go. Go to System Setup and Repository, On-Site W, and search. So let's do that. So I need the application to be open but not logged in. Oops, that's On-Site W service. We don't want that one. Okay. So we're in Pro. We go to System Setup. Import, no, not import Spectra, On-Site W setup, select application on localhost, because it's on my computer, and select project. I think that would have been test, right? Let's see. Okay. Okay, a user must define the project to download the data to. Okay, so let's download it to a new project. So we'll create a new project called import. Okay, and download data. Okay. So I think all the data have now been moved off of the On-Site W application and onto the into MicroNIR Pro, and we can verify that here. So we're going to retrieve some data from import, and here are all of the spectra that I have collected. Okay, so that worked. Right. Now, you had asked Ziv about how to import data from an older version of the software. The best way to do that is to go into System Tools, System Setup, Import Spectra, and here you would browse to the C MicroNIR Pro directory or wherever the spectra are stored, and you highlight the name of the project folder, and there you go. And you can select all and import these into a new project called, let's say, that. You can also preview the spectra and then click upload, and this will create a new folder in which will be called this in C MicroNIR Pro method development. Okay? Okay. What else can I show you?
I have one question, please, Ed.
Mm-hmm.
If we build a model and we want to update it to add more spectra and more data, reference data, how can we update it, or we need to build it from the beginning?
Yeah, no, you can do that. So we'll go back to developer space, data analysis, PLS. We load up that model. And now we can do a couple of things. Useful thing to do, this isn't answering what you asked, but it is useful. A useful thing to do would be to do a validation, and to do that you say define set validation, then retrieve the spectra as we did before, and use it to use those new spectra as a test set to validate your method, and that's a much better means of qualifying your method than your model than doing the cross validation that we did before.
But it's not adding new data.
No, it is not. So it's easy enough to remove spectra from this model. We can remove those 3, for example. And if I want to add in more spectra, I can go here and bring in these new spectra, which, as you see, are quite different. Now I have to go to reference data again, and you see that the new spectra that I've added, they want a reference value to be input. So I do that, and then I say regenerate, and away we go.
Great.
Okay. And the same would be true for an SMV model or a PCA model. And you can save the model as version 2 or anything you like. Okay.
Excellent.
Great. All right. Any more questions? I do have a call at 10, so we should not go for more than another 10 minutes.
I think from my side it's okay. I need to work more with the instrument.
Okay.
So if I have another question, I will go to Asaf.
Okay, great. What are you? I'm sorry, you were measuring chickpea protein in chickpea flour, right?
So in chickpea seeds, chickpea, sesame, cowpea, soybeans.
Mm-hmm. Okay.
All legumes.
Okay.
For several parameters.
Mm-hmm. And you dry them first, the samples, to a constant moisture level, or not?
We have to. The only way to harvest it when the plants are dried.
Right. I see.
Dried, and then we harvest it, extract the seeds, and then take the measurement in our facilities.
Mm-hmm. Okay.
But it's sun-dried, no, Ziv? It's outside, it's drying.
You're drying out.
Not controlled environment.
No. Drying in the field, or maybe put some spraying on it or something like that, but not in the oven or something like that.
Mm-hmm. Okay.
Just Okay. Thank you very much.
Okay, very good.
Have a lovely day.
Thank you very much, Ed.
Thank you.
We really appreciate if you can send us the movie by I don't know
Dropbox,
any
I think.
kind of,
Yeah.
Dropbox or something like that.
Okay,
Yeah.
I'll be happy to do that.
Thank you very much, Ed. It was very helpful. Thanks.
Okay.
That's all for me.
Yep.
Thank you very much. Have a lovely day.
You're very welcome.
Bye. Bye.
Bye, Ed. Good day.
Let's see. How do I turn this off?
Just turn off the computer.
And I stop recording. How?